Yeah, you stick around long enough and I'll teach you how to do that too. Yes, it has in fact been 3 years, almost 3 years since the last time I did this. I've probably learned a little more since then, so we got a little more to share. Got a much better OBS stack of scenes for you. Here, let's start with this one. You can see I got this beautiful sort of rounded surface right up here. It separates me from the rest of the display, but keeps things manageable. And I'm going to turn down the background music just a tad at my end, and we'll see how that works out. All right, so what we're going to do is mostly experimental today because I haven't streamed in a very long time, so we're going to see if I remember how to do it. But what I want to do is explain how multiplaning, which is a very old animation technique, can be used to create the impression of depth in a 2D environment. And without further ado, let me demonstrate how that works. Have a look at this. In fact, I'm going to back myself out of this for a moment. We'll blow things up to a little bit bigger image and run this project. And Unity, of course, taking its time to get started. One gets used to that in the Unity development business. And here we go. All right, so in the apparent foreground, you can see the trees are moving along at a rate maybe comparable to what you would experience if you were riding by in your car, bicycle, what have you. Off in the distance, we see the mountaintops. They're moving too. You can tell they're moving by looking at the starry sky in the most distant background. Now, stars aren't moving at all. They're too far away. So we've actually created a fairly convincing illusion of depth with the trees much closer and the mountains farther away, but not infinitely far away. And then finally the stars, which are infinitely far away. This is called multiplaning. It's called multiplaning because each of the separately moving parts of the image are on their own plane. So the trees all move together. Now in a more sophisticated version of this, we might have trees on several planes. Even every tree could have its own plane. The important thing to know about a plane is that the parts that are not moving, the parts you see through, are transparent. And that's what lets you see the more distant plane. So the closest plane is the trees. Behind that is a plane with the mountains and also this fixed green grass below. And then above the mountains is also transparent. That allows us to look beyond them through their plane to the third and last plane, which has these fixed stars on them. And the code for this is decidedly simple. So let's have a quick look at the code. I'm going to bring myself back into the picture just to make sure this works. And let's have a look at the code. Now, I called it offsetter because what I'm doing is I'm changing the texture offset of the texture used in the material that puts the picture on the polygons in my scene. So let's have a quick look at those. The stars are back here in the distance. You can see this really is 3 separate layers. Something to understand about most 2D games is they don't really exist in 2 dimensions anymore. They exist in stacks of 2-dimensional surfaces. That's what those planes are, the multiplanes. And it looks like I may have misled you a moment ago when I said that the grass was part of the mountain backdrop. It actually isn't. The grass goes with the trees, but you can't tell the difference. Okay, so on the hills quad, I've got a copy of my offsetter script. You can see that's listed here. And I have a rate of change, which I call dx, negative 0.01. And on the trees, which are on this plane closer to the camera, I've got a 10 times higher dx, negative 0.1 instead of negative 0.01. All right, so let's go have a look at that script again. It's real simple. I think this justifies letting you see the whole thing. So again, I'm going to blow myself out and blow my desktop up so you can see it. So here's that dx value. Remember, Unity will always capitalize the first letter of your public member fields. So if you have a separate field, the only thing that distinguishes it is that it's capitalized at the first position. They'll look the same in the Unity inspector. We have some private members, the material and the offset. And always a good idea when you can to get references to anything that won't change, anything you only need to get once in your start method. So the offsetter begins by obtaining a reference to the material for the game object that the offsetter is on, and then it uses that to get the offset of the main texture in that material, and that texture is the image that we saw moving. Okay, now those two things won't change. From then on, every time update gets called, I'm going to modify the X component of the vector2 object that defines the XY offset of the texture in the material. And then I'll put that offset back into the main texture offset. So it's a slightly complicated looking expression. Don't let that worry you. What I do is I take whatever the pre-existing offset is, I multiply that by the rate of change I put at dx. Now remember that Unity works in meters, so this rate is meters per second. I multiply the meters per second that I want to move my texture by. I multiply that by the time that has passed since the last call to update. Time.delta time gives me that time in seconds, which is what I want if dx is in meters per second. Now, you don't want values to grow limitlessly. If I just added time.delta time times dx to offset.x and put it back into offset.x over and over again, offset.x would grow and grow and grow and grow. And you'd be surprised to find out that within only a week or two, you would get to a number so big that in the range of a float, which is the type of offset.x, adding a little number like this to it, time.delta time, would be lost to round-off error. In other words, if offset.x gets too big, offset.x plus dx times time.delta time will be computed to be the same as offset.x. It'll round off that tiny little change. To prevent that from happening, we're always going to take the remainder of 1, because the offset really only ever has to be a value between 0 and 1. That controls how far the texture is moved in the material. Now, a little tip for you. Many people call this percent sign in both C# and Java the mod operator, short for modulus. Well, a modulus is the number of distinct digits you can have in a single place in a number. A mathematician might put that another way, but that's the way I'm going to put it for now. And what I want you to be aware of is that the modulus is always positive, but a remainder can be negative. Imagine a number like -9 divided by 5. It would have a remainder of -4. Well, if you use this percent sign operator to do that operation, that's what you're going to get. You'll get a negative number. A true modulus is always positive. There is a way, a little bit more complex in 2 steps, to get a genuine mod operation out of the remainder. We don't need it today because we know we're always adding a positive value to this. Well, actually, in this case, it isn't positive, is it? It is in my starting value of 1, but I set it to a negative value in the inspector, so I'm actually subtracting. But that's okay, because again, I want the actual remainder here. So whatever this grows to be, if it gets to be too big above 1 or -1, when I divide it by 1, I'll have some number between 0 and either -1 or 1, which is what I want. And then I put the completed offset back into the main texture offset. And that's all I need to do. Now, how does that work? Well, if you go back to Unity and you look at the materials, if you look at the hill material or the tree material, you can see I've chosen to use the unlit transparent shader. And each of those has an offset value built into the shader. That's part of what you get when you use the unlit transparent shader. You can drop any texture you want into this texture box here, and if it has an alpha value, it will use that as a transparency. When you modify the offset, look at what happens. It changes the position of the texture in the material. Well, that's how we're getting this continuous animation. I'm slowly changing from 0 to -1, and when I get past -1, I go back to 0 again. That's what that remainder operation did for me. If we run this game without maximizing, and watch that offset value. I think we'll see it change. Let's try that right now. Ah, well, this happens because of a subtle feature in Unity. When you obtain a reference to a material in a game object in a running game, you actually get a clone of that material. So we're not going to modify this texture directly, and that's a good thing. We wouldn't want that texture to be modified prior to the next start of the game. So if we go and we look at our trees, we can see the texture is having its offset modified here. And if you look at the cloned copy, notice it says instance here. That tells you this has been cloned because we obtained a reference to it. Our offsetter script is actually changing the offset of the texture in this material. You can see it's changing at about the speed we wanted it to, 1/10 of a meter every second. Look at this digit right here, just to the right of the decimal. If we look at the hills, we'll see the same thing, but 1/10 as fast. And that's how we get this multi-planed apparent depth effect. Pretty cool, huh? All right, well, that was a pleasant short return to the streaming experience. Just give me 1 second, everybody. All right. Well, like I said, this was mostly an experimental exercise just to make sure that my streaming system worked again and that I remember how to do it. We'll be back with many more things, and I do take requests. I also teach at the university. If you're interested in knowing more about that, I'd be happy to talk to you about the offerings at the University of Maryland in College Park. But until next time, peace out.